So previously we've learned the concept of Euclid's division lemma. Then we saw how to write a pair of integers using Euclid's division lemma. For example, 17 and 6. 17 is equal to 2 multiplied by 6 plus 5, right? So now we're going to learn how to solve some applications of Euclid's division lemma. So let me take an example. Show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer, right? So how do you solve such type of questions? See. Here we have to show every positive even integer and every positive odd integer. So the first step is let a be any positive integer. So the first step is let a be any positive integer. Now what is Euclid's division lemma? See, it says that a is equal to b into q plus r. I want you to compare the right hand side with these statements we have over here. See, here we have 2q and we have 2q plus 1. I repeat, this is what we have to show. So if you compare these two expressions, what do we observe? The value of b is 2. See, what is b? It is the coefficient of q. So here 2, here also 2. So let b be equal to 2. So let a be any positive integer and let b be equal to 2. And let b be equal to 2. Why did I take b as 2? See, if you compare what you have to prove with over here, see what is b? Coefficient of q. So here 2, here 2. So bq plus r, so b is equal to 2. So let a be any positive integer and let b is equal to 2. Now let's apply the Euclid's division lemma. So first let me rub this off. So let a be any positive integer, let b is equal to 2. Then write over here, applying Euclid's division lemma. What does Euclid's division lemma say? It says that a is equal to b into q plus r, where r is greater than equal to and less than b, right? So plug in the values. So here we have a. So a is equal to, what is b? It is 2. So instead of b, I'll write down 2 over here. Copy the remaining as it is. 2 into q plus r, where r lies between, that is greater than equal to 0 and less than b. What is the value of b? It is 2. So r is less than 2. I repeat once again. See, let a be any positive integer and let b is equal to 2. Apply Euclid's division lemma for any pair of integers a and b. What does Euclid's division lemma say? A is equal to b into q plus r, where r lies is greater than equal to 0 and less than b. So what is a? It is a. What is b? It is 2. So r is greater than equal to 0 and less than 2. So we have a is equal to 2 into q plus r. I hope this much is clear. So now what are the possible values of r we get from here? So see, possible values of r is greater than equal to and less than 2. So what are the possible values of r? R is equal to 0 and r is equal to 1. See, r is greater than equal to 0, so 1 value is 0. What is greater than 0, 1? Is 1 less than 2? Yes. Can I take 2? No, because r has to be less than 2. So possible values of r are 0 and 1. So take these two cases when r is equal to 0. So when r is equal to 0, so what will this expression become? It will become a is equal to 2 into q plus r. What is r? It is 0. So 2q plus 0 simply 2q. So a is equal to 2q. I repeat, when r is equal to 0, a is equal to 2q. Similarly, when r is equal to 1. So when r is equal to 1, what do we get in this expression? A is equal to 2 into q plus r. So plus r, what is r? It is 1. So the two possible values of r, 0 and 1. When r is equal to 0, a is equal to 2q. When r is equal to 1, a is equal to 2q plus 1. Now 2 multiplied by any integer, this will always give us an even integer. So this implies a is an even positive integer. I repeat, see what is a? It is basically any integer. Now a is equal to 2 into q. That means 2 and q both are factors of a. So a is divisible by 2, hence it is an even integer. Similarly, 2 into q plus 1. 2 into q is even plus 1 is an odd number. So this implies a is an odd positive integer. Now this is exactly what we have to show. So 2q, we have to show that every positive even integer is of this form. So a is an even positive integer of this form, and when it is an odd positive integer, it is of the form 2q plus 1. So hence we are done. See, let me explain this concept once again. See, a is any integer, a is equal to 2 into something, right? So see, for example, if I ask you what are the factors of 6? So we'll say 6 is equal to 2 multiplied by 3. So 2 and 3 both are factors of 6. If I ask you, tell me the factors of 6. So we'll express 6 as product of two integers, 2 into 3. So here both 2 and 3 are factors of 6, right? So whenever any number is written as multiplication of two numbers, for example 2 into q, that means both 2 and q are factors of a. Now because 2 is a factor of something, that means this is divisible by 2. If any number is divisible by 2, it is an even number, right? So a is 2 into anything. In general, you can verify 2 multiplied by anything is an even number. See, 2 multiplied by an odd number, even. 2 multiplied by an even number, again even, right? So basically 2 multiplied by any integer is even. Now any integer plus 1, any even integer plus 1 is odd. Take any even integer, 4, 6, 8, 10. Add 1 to it. 5, 7, 9, 11. So any even integer plus 1 is an odd integer. So whenever you have a number of the form 2 multiplied by a number, it is even. 2 into a number even plus 1, it is odd. So this is an even integer, this is an odd integer. So this is how you solve such type of questions. Let me do a recap. The first step is let a be any positive integer. Now how do we choose the value of b? Look what is given over here. Compare this with bq plus r, so b is equal to 2. So let a be any positive integer and let b is equal to 2. So by applying Euclid's division lemma, what is Euclid's division lemma for any pair of integers a and b? A is equal to bq plus r, where r is greater than equal to and less than b. So a is equal to a, what is b? It is 2. So we get this value where r is greater than equal to 0 and less than 2. So come till here. After this, write down the possible values of r. So what are the possible values of r? 1 is 0 and 1 is 1. Why not 2? Because r has to be less than 2. Now check each value of r. When r is equal to 0, what does this become? 2q plus 0, that is 2q. When r is equal to 1, what does this expression become? A is equal to 2q plus 1. So 2 into q means it has to be even. Even plus 1, odd. What is a? Any positive integer. So this is any positive even integer, any positive odd integer. So because a can get only two values, what did we assume? We assumed a is any positive integer. So any positive integer can take only two forms, either 2q or 2q plus 1. In case it is 2q, it is an even number. In case it is 2q plus 1 odd. So what have we shown? Any positive integer a can take only two forms. See, we have only two values. It can take only two forms, either 2q or 2q plus 1. This is always even and this is always odd. Why? 2 multiplied by any number is even and even plus 1 is always odd, right? So this is how you solve such type of questions. So we'll be taking more examples of this type, so it'll slowly become clear, right? Nevertheless, this is how you apply Euclid's division lemma to solve such type of questions.